All right, good afternoon, everyone. What we're going to do is finish up what we were talking about on, make sure this volume is working. Hopefully you can hear me. We're going to finish up chapter 2. Where we stopped off was 2.3, which was energy and chemical reactions. One of the things that I always like to do is make sure that we can define what we're going to go over. So the ones that we're going to go over in this part will be pretty quickly, just because these are terms that we already know. Like we know what energy is, we know what work is. Those are all some of those same things that we use time and time again. So let's go ahead and get started. All right, energy. We know energy is just the capacity to do work. And we often say, today my energy is low, or, yesterday my energy was low, or I have a lot of energy. When you have a lot of energy, of course, you have a great capacity to do a lot of work. Potential energy is what we call stored energy, and that is the piece that gives us the most let's say it this way, that's the piece that allows us to have the most fun on roller coasters, because if you ever notice, they take you up this steep hill and then they pause you right here. So all this stored energy, that's what we call potential energy, and then it drops you down. As it drops you down, you switch and you go into kinetic energy, which is movement. So potential energy up here, that's as when you are looking down and you're still, and it kind of tilts you just a little bit. And then the kinetic energy goes in as we keep going. So kinetic energy. Chemical reactions and chemical equations, those are very important. You'll see them more so in chemistry than you will here. So I'm going to briefly go through these. Decomposition, synthesis reaction, exchange reactions. Again, that's more chemistry, so I'm going to kind of skip through this one. And remember, anything that I skip through, you're not held responsible for. Okay, reaction rates, very, very important. When we have molecules that are going to coincide, they bump into each other, they contact and they alter how things are supposed to occur. So reaction rates will increase, and that's the ability for something to move or something to be activated. Temperature will definitely do that. A catalyst is present. What is going to shift it to make sure that the reaction moves at a higher speed? These terms, very, very important. Metabolism. Metabolism is one of the things we talked about, which were one of the characteristics of cells, and how we know that part of the cell theory is that it has to have metabolism. And when we think about metabolism, usually we're thinking about hunger. We'll say, someone has a large metabolism, someone has a high metabolism, or someone has a low or slow metabolism based on their body fat percentage or how they look. Like if we see someone that's extremely small, we usually say, oh, he or she has a high metabolism. And if we see someone that who is larger than we think, we'll say, well, that person has a slow metabolism. So that's what's going on. But metabolism means so much more than that. It's only a section of it. So metabolism is just all chemical reactions of the body. Then we have catabolism. Catabolism is when you take something that is very complex. So you take these complex molecules and you break them down into something much simpler. It will be like taking, let's say, something very complex, let's say cereal. We take cereal, we'll use Frosted Flakes. We have Frosted Flakes. Once we put it in the body will break it down to get exactly what we need, which is the most simplest thing, which is sugar. So we take something, a carbohydrate, or if we said a potato, let's say potato. Potato is a carbohydrate. What the body wants to do is break that complex molecule down into something very simple that we can use. So we go from something like a carbohydrate down to a sugar, which will be glucose. And glucose, we know the body can readily use. Anabolism, if you think about anabolic steroids, so those bodybuilders that have huge, huge muscles, which you see I don't have any, what those do is take something very simple and build it up. So they take something very simple like protein and build it up to an amino acid. And amino acids are much more complex. What they are or tend to be 6 to 10 to 15 different proteins combined together to make one amino acid. Okay. So catabolism and anabolism are inseparably linked. Oxidation and reduction, again, more chemistry. We're dealing with electrons. I'm going to skip past that. Now, important piece that we need again is carbons. When we're talking about organic chemistry, we're always going to talk about compounds that deal with carbon. If we're talking about inorganic, then we're going to deal with compounds that don't have carbon. So these 4 categories of carbon compounds we see over and over in the body: carbohydrates, lipids, proteins, and nucleic acids. Carbon, we're not going to get more so into the specifics of valence electrons. I want to talk more about how they actually work. So with carbons, we know we can make glucose. With carbon, we can make carbohydrates. So many different things that we're going to see how these macromolecules, which are these right here, these macromolecules, how they play a role in our everyday life. Now, a part of this is going through some more chemistry. We have something called dehydration synthesis and hydrolysis. The key part of knowing about dehydration synthesis is at the very end, water is going to be the byproduct. So when you do a chemical formula, you're going to see H2O at the very end. Hydrolysis is when we're going to add water. So it's the opposite of dehydration. So dehydration produces water. Hydrolysis is going to add water. So here we go. So dehydration, we have monomer 1, monomer 2, and what do we end up with? A byproduct of H2O. Over here with dehydration, we see that water is added and that water is not a byproduct. Because water is not over here, we know this is hydrolysis. Okay? Because water is here, we know it's a dehydration synthesis problem. I know that sounds counterintuitive because when you think of dehydration, you think of lack of water, not a product of water. So going back to carbohydrates, you don't need to know the formula, but what you do need to know is the importance of it. So let's start with the most simple form of carbohydrates, and they're called monosaccharides. These carbons cannot be broken down any further. These carbohydrates can't. So it'll be things like glucose, galactose, and fructose. We hear fructose a lot in the news when people talk about drinks having high fructose corn syrup. This is what they're talking about, very simple sugars. And so glucose, what we talked about is blood sugar. When we were saying negative feedback, and we were talking about glucose, and we were also talking about insulin. Now, to build up from the monosaccharides, we have disaccharides. So simple is just a sugar made of 2 monosaccharides. So here are some examples: sucrose, which is table sugar; glucose, which is fructose; lactose, which is sugar and milk; and glucose plus galactose.